Hey coders, so today we're actually going to be talking about one of the most powerful data structures in computer science called linked list. So you can think of linked list as a data structure whereby we're trying to store elements in a sequential order. So these elements are connected to one another. So one of the reasons that we use linked list is because they have a very efficient space, right? Meaning that the data structure itself is very flexible, so it shrink or it can grow based on the elements that you're adding to the data structure. Okay, so let's go to the whiteboard and let me explain this data structure in more detail. So we can think of it as we have elements. So let's say 0 is connected to 1, 1 is connected to 2, 2 is connected to 3. So these elements are connected to one another, and this is what we call a single linked list, because we have one way these elements are connected to, right? So there is another type whereby it's called a double linked list, whereby these elements I always think of it as two ways. So these elements are connected this way, right? So this is also known as double linked list. So we're going to be looking at both of them today, and I will actually showing you how you can remove elements in this data structure. Okay, so the first thing that we're going to be looking at, I will take you to the code, which is we're going to see how we can actually print all of these elements inside this data structure. Right. So before we do that, I want you to kind of like understand that this essentially is called a node, and as we can see, this node is essentially has a properties, and the properties it has next. This next simple denotes that it's actually pointing to the second node, and it is also, if we're talking about the double linked list, it is also previous. Previous node, which means that it's pointing to the node behind it or something like that, or to the previous node, right? So we have to create a class all the time. If we want to store a data element, we have to create a class. This class is essentially going to give this data point these properties, right? So each point is going to have these properties here, because that's how we know that these elements are going to communicate to one another in a way. So let's get back to the code, and I'll actually show you how we can create a class that represent these nodes. So firstly, I'm going to create a class, and I'm going to call it a node, and I'm going to say initialize, give it a self, and obviously we're going to take a data point, right? It could be 1, just like I showed you in the data point in the whiteboard, right? Or it could be any value that you can think of, right? So the first thing that I'm going to do, I'm going to say self.data equals to the data point. Then I'm going to say self.next. This is the node, the next where this point is going to point to, right? Let's say the data point was 1, so the next is going to denote where this point is going to point to, right? So initially when we start, it's going to point to none, because we don't know which elements are inside there. So we just have to write another class to make it point to the element that we want it to point to. So similarly, we're going to have another variable in the denoting a previous node, so it's gonna also point to none. Okay, so we're gonna have to create another class whereby we can actually now create a linked list. So this is a node. So what we did here was to say, if we have a data point, we're just giving it those properties that we spoke about, like we just giving it those properties of next and previous, right? So what we want to do now is that we want to essentially create a double linked list. Okay. So we're just going to create it now. So a double linked list essentially it's going to take the properties. Initially when we define this, it's going to always start with an empty element, so which means that we're gonna have to have an empty head. So we're gonna do something like this, and it's gonna be self dot head equals to none. So whenever we start with a double linked list, the head will initially be none, and we're gonna have to then give it a data point that is going to be head. Okay, I hope that kind of like makes sense, but just be with me now and I'll show you everything. Now we're gonna actually see how we can actually print the data element inside a linked list, right? So I'm just gonna create another function. I'm just gonna call this function print nodes. I think call it that way. Then it's gonna take self, giving it self because we know that this self.head is going to essentially represent the double linked list, right? Meaning that that's the point, that is the starting point of the linked list, so to speak. So take self, and it's going to be node equals to self.head. All right, so what I want to do is that I want to loop through all of those elements inside the node, right? The self.head, I meant to say, sorry about that. So we're gonna say while node is not none, so we're gonna say print data node dot data, and we're gonna say node equals to node dot next. So let me explain what's going on here. So what we're doing is that we're saying while this node is not none, because we know that we're gonna have specific elements inside our linked list, right? So obviously, like, we can have 5, so we can, let's say we have 5 elements inside there. Then if we continue looping through all of these elements, obviously we're gonna come to an end, right? So we say when we come to an end, that means this node is already none, right? So we have reached this node.next. I don't know if that makes sense. Okay, let me take you to whiteboard so that I can explain this more clearly. So what I'm saying is that we have these 4 elements. So we're gonna loop through this. We're gonna go from 1, we're gonna go 2 and 3. And you can see that if we try to go again, this is none. So we have reached our limit. So if we reached our limit, then that condition won't be true anymore. So we're gonna print all of these. Like I said, these numbers are represented as data. So that's why there we said node.print data. Okay, so let's go back to the code. So that's what we do. We say when node is not none, so this while loop will continue until we've printed all the elements inside the linked list, if that makes sense, right? So we're gonna run this through. If you don't understand, I'll probably come back to this, but for now, just think of it as we're trying to like print all of the data points inside there. So now the fundamental question is, how can we then add the data into a linked list, right? So I'm just gonna say def add, I'm just gonna call this one add element, right? So we're gonna take elements. So let's think about all the properties that we're gonna need as we add an element. So the first thing that we're gonna need self, right? Because like we said, self represent the linked list itself, like the double linked list. So it's a self.head, it represents the all the elements are inside there. The second thing that we're gonna need is the element that we wanna add, right? So I'm just gonna call this new node because that's what we want. Okay, when we're here, what is it that we have to do? The first thing that comes to my mind is that this new node, we're gonna add it as a data point, right? As a number like 1, 2 or something like that, right? But now as we add it, it wouldn't have those properties of next and previous. So we need to give it those properties, right? So how can we do that? We're gonna say new node equals to node. So we're calling this class because we want to give it these properties of next and previous. So which means that we're going to say node take new node. So what did we just do there? We just gave this new node properties of previous and next. So it have all of those properties now. So this is good. Say new node dot next. We're adding you, so we want you to point towards our self.head. So another thing that we need to think of is an edge case, right? So I'm gonna say if self.head is not none. So if self.head is not none, then I want the self.head.previous to point towards the new node. So remember that this is a double linked list. So if I point you, you need to point me, something like that, right? So you need to say self.head.previous equals to a new node, because self.head now it's going to become the second node. So it has to point towards the new node essentially. However, let's think about it, right? If self.head is none, then obviously like that means the linked list was empty. So which means that self.head is going to become the new node. Okay, so let me take you to whiteboard and try to explain to you what I mean by this. So what I'm saying there is that let's think about it this way. Let's say we have a linked list and this is 1, 2, and 3. So they're all pointing to one another, just like I showed you. And we want to add a new node. So we want to add a new node. So as we add this new node, the first thing that we want to do is that we want to make sure that it's pointing towards this. So we call this in our code, we called it self.head. So we call this self.head, and it has all of these properties whereby it has all of these, it's carrying all of these nodes inside the memory, right? So we're pointing it towards there, but this node is not pointing towards this node. So what do? We say self.head.previous, because it has all of the properties, right? We spoke about this. So we know that it has the properties of previous. So there's that property. So we just want to say self.head.previous equals to new node. So this then will then make this point here, right? So you can see that this will then become the new self.head. Okay, so that's what we just did there. We just added a new node as to the end. Okay, so let's try to see if our code works. So what I did here was to say push. I think we're gonna say let me just call this push element. So we're gonna say push element, whereby we're pushing all the new nodes. So you can think of this, we're pushing 1, 2, 3, and we're gonna print all of the nodes. So let's run this and see if it works. I think it's connecting, so it might take a while, but anyway, if it's gonna take a while, we can in the meantime continue. Okay, okay, it's connected. Sorry about the delay. I think it was because the double linked list is not defined. So what do we need to do? What did we call it? We called it double linked list. Yes. So I capitalized that. Cool. So perfect. You see, we just printed all of this. So we printed 3, 2, 1. So which means that how we adding these, it's working. So you can tell that we firstly added 1, right, which is here. We secondly added 2, because we remember that we're adding these things at the beginning. So that's why here you see 3. So that's why we're pushing this at the beginning. So like they are connected. So I add 1, add 2, I add 3. Okay, so I hope that makes sense, guys. So now we're gonna write another function whereby we say we want to add the element at the end this time, not at the beginning. So we want to add the element at the end. So now we're just gonna push a new node towards the end, right? So we're just gonna say push node, push end. I think I will call it that way. Then we're gonna take the linked list itself, and we're gonna take the new node that we're gonna push, and we're gonna say new node, giving it the properties. So we're gonna call the node new node. Then what we're gonna do, this is where adding an element at the beginning and ending at adding an element at the end differ. We know that an element at the end is going to point to none because it's at the end, right? It's not going to point towards the next node. There is no new node. There is no next node, I meant to say. So which means that we're going to have to say new node dot next, right? Sorry about that. I think, yep, perfect. So we're going to say new node dot next equals to none, right? So before we continue, let's think about an edge case. Let's say we want to add this new node, but we're adding it on an empty linked list. So that means the properties are going to be different, and how we're adding it is going to be different because we want to make self.head point towards this new node. So how can we approach something like that? We're going to say if self.head, right, is none. So this is more like an edge case. It's none. So we just wanna oops. Yeah, autocomplete today is just getting out of hand. But anyway, so if self.head is none, what we wanna do in this case is that we want to make sure that the new node previous is pointing to none, right? New node, because we're adding this to the end. Remember, so new node.prev is gonna point towards none. Right, then we want to take self.head equals to this new node. I hope this makes sense, guys. So what I'm doing here essentially is that let's assume that there was no data in the linked list, right? So we're just saying because we're adding this to the end, so let the previous point to none and take the self.head point to this new node. Okay. However, if we have data inside the linked list, then how can we then add an element at the end, right? So we're going to create a new variable, which we're going to call last. And essentially it's going to take the properties of self.head. And we're going to loop through this. We're going to say while last is not none. So what we want to do in this case is that we want to say last equals to last dot next. So like I showed you when we're printing, the element. So we want to go towards the last element, right? That's why we're saying last. Actually, we have to say last dot next here because you're saying the last element is not none, right? So the current element is going to be pointing to none. So that's what we're doing essentially there. We go into the last element. Then because now we have the last element, right? We're going to say last element. We're going to say new node point towards the last element equals to last. New node dot prev equals to last. Okay, and we're gonna do the same thing. We're gonna say last dot next, just point towards the new node. Okay, guys, hope this kind of like makes sense. Hope it kind of like makes sense. But essentially, what we're doing at the high level is that we're looping towards. Okay, let's go to the whiteboard so that I can explain this more clearly. So it's like we're looping through. We can think of it like we have all of these nodes. Right, so we have 1, 2, 3, and 4. Right, we're looping through all of these up to until we get to the end. Right, as we get to the end, we wrote a query to say if node.next is none, meaning that if this is none, is pointing to none, then stop. Right, because now we have this element, so we're just saying so this last element dot next equals to new node, right? So we're saying this last element point towards the new node. And what about the new node? So we did the same thing. We just said new node, right? Sorry about this. New node dot previous point towards last, meaning that point towards this. So that means this new node essentially is going to point this, and this is going to point there. That's what we just did. So don't be confused by that while loop. So that is just a technique. It's called traversing a linked list. So that's how we traverse a linked list, meaning we just go from one point to another in the linked list. So that's what we did there. Okay. Okay, cool, guys. Now we're going to look at append after a node. So I feel like this one is going to be actually confusing. So I'm just going to go straight to whiteboard and explain it from this perspective, right? So what we're going to do is that think of it like we have 3 nodes. We have 1, it's going to be 2, and it's going to point to, let's say, 4, right? So these we know that they're pointing to one another, right? This is pointing here, this is pointing here. So let's say we want to add 3. This is a new node, right? So we want to add this new node. How can we add this? So the first thing that comes to my mind is that, okay, we're going to have to say whatever this previous node, this is going to be called previous node. So whatever previous node is pointing to, we want it to point, we want new node to point to that. Okay, so from code perspective, we're gonna say something like new node dot next. We want you to point towards what previous node dot next is pointing to. So it's like saying point towards this. That's it, right? The second thing that we're gonna do is that we're gonna say previous node dot next point towards the new node. So something like previous node dot next point towards new node. So that means we're gonna remove this part here. We're gonna remove this part because previous node is not gonna point here anymore. We just said it must point towards here. Okay? Then what we're gonna do is that we're gonna say new node dot previous, right? The previous point towards previous node. So this previous is gonna point towards here. Okay. So what are we left with now? We left with previous node. Previous node. Next node from previous to point towards the new node. Okay. How can we get this element here? We can get it by saying previous. We can get it by saying new node dot next dot previous. You see what I did there? I said new node dot next. We know that is pointing to 4, and we're gonna say dot previous, meaning that we're accessing the properties of this. We're accessing the properties of this. So we're saying equals to a new node. So that means we canceling this point here. We're gonna remove this. This will be removed because we just said new node dot next dot previous point towards the new node. So this is gonna point here, right? However, when we write this code here, we're gonna write it with the condition to say if the new node, if this was not a none, because this could have been a none, this could have been pointing towards a none. It could have been an end, the last element, so to speak, right? So we have to kind of like have an edge case. So let's go and try to implement something like this, right? So we're gonna say def append, append node. So we're gonna take self and we're gonna take previous node, just like we spoke about it now, and we're gonna take the new node. And what we're gonna do is that we're gonna have to cover all the edge cases, right? So we're gonna say something like if the previous node, what we have been given to, it is actually none, then we just wanna return, because we can't add anything because the previous node is none, right? It does not exist. However, if it does exist, what we wanna do is that we want to do what we just spoke about. We're gonna say new node dot next point towards what our previous node was pointing to. New node dot next equals to previous node dot next, right? Similarly, we want to say previous.node.next point towards the new node. So we're gonna say something like previous.node.next point towards the new node. Okay, and we also want to say new node.previous point towards the previous node. So I hope this kind of like makes sense now, right? It's just like creating pointers, guys. That's what it is. So we just want to say new node previous equals to previous node. Okay, hope this makes sense. So new node.next point towards whatever previous node was pointing to, and previous node.next point towards the new node, and the new node previous point towards the previous node. Okay, so now this is an edge case because we have to say if the new node.next is not none. So we want to be smart here. So we can imagine that previous node could have been pointing towards none, right? It could have been a last element, right? So if it was a last element, then it's fine. However, think about it. If it was not a last element, that means we want to do something different. Okay, so we want to say new node dot next dot previous equals to new node. So what we're doing here is that we're saying whatever new node is pointing towards, we want that thing previous to be the new node. That's what it is. That's like what's inside this code, guys. So we're just gonna have a return, right? So we have delete functions and delete at the end. So it's the similar thing, and this will be a task for the viewers. Can you delete at the beginning? Can you delete at the end? So it will be a task for the people who are watching this video, right? So but it's literally the same thing. You just need to say when you delete something, obviously remember that you have to give it none. So so you just have to like, it's the same thing that we just did here. So as we add to the beginning, it's just that now you have to like give it a none or something like that. So however, if you want the solution for these two, I'm gonna post them on GitHub, but just try them so that you can solidify your understanding. So yeah, guys, that's all from my side. I think we have everything. We've covered everything. We can try to see if all our functions, they work first, but I think they do. So let's give it a try. So here, what we want to do, we're pushing all of the elements, and here we're pushing after. So meaning that we're pushing, we're appending node. So I think that's what I called it here. So we're just gonna push this. So I'm pushing this after, let's see, int object has no attributes next. Oh, yep, I see where the problem is. That's because we forgot to give it the new node. Yes, guys, we forgot to give this the new node the properties, right? Oops, new node. I think now it should work. Perfect. So you see here, we just added 5. We just added it after 2 because we said head.next. What was the head? It was 1, and the next is 2. So we added 5 after 2, which is this, right? And we can also add at the end. So I'm just gonna add 4 at the end. So it's gonna be at the end, right? As you can see, it's here. So all of our functions actually works, right? So try it, guys. Hope you enjoy the tutorial. If you did, just hit a like button and don't forget to subscribe. Thank you, guys. Cheers.